So let's talk about multiplying and dividing fractions. So typically when we're learning the different operations we can do with numbers, the first things we learn to do are add, right? I'm talking like real, when we were real little. And then we learn to subtract, multiply, and divide. Well, I'm going to cover multiplying and dividing fractions first because it's actually simpler than adding and subtracting fractions. So when we're multiplying two fractions, we're finding the product, right? If I multiply new numbers, that I get is their product. And what I do in order to multiply fractions is I just multiply the numerators and multiply the denominators. That's it. So if I had 2/5 times 3/7, I would multiply these numerators. I'd have 2 times 3 over 5 times 7, which would give me 35ths. I'm making this video at like 7 a.m., y'all. So I have 6/35. That would be my fraction. The next thing I'd want to do is see if I could simplify. Well, I can't, right? 35 is the factors into a 5 and a 7. 6 is a 2 and a 3. They have no factors in common, so I'm all set. Just a friendly reminder, you need to always simplify your fractions. Always simplify. Yeah, Bobby even agrees. Good girl, Bobby. So here's kind of a representative model that might help you better understand why when you are multiplying fractions, you multiply the numerators and multiply the denominators. So let's look at this fraction tiles model. So I have 1/2 times 3/4. So when I take 1/2 times 3/4, what I really want is 1/2 of 3/4. So if I start with 3/4, right, I've got 1, 2, 3. And if I want to find half, I need to divide them into two groups, okay? So what we're going to do is I'm going to break them in half, and that's going to be making them into eighths, right? If I have half of a fourth a cup, that's an eighth. Fractions, sometimes it's really helpful to think about baking. If you aren't a baker, maybe you should start. So we break them down into eighths, and then I take half of that, and I get 3/8. Okay, so if I want 1/2 of 3/4, that's 3/8. Let's check that this works multiplication-wise. 1 times 3 is 3. 2 times 4 is 8. As we can see, they are equivalent. They're the same. So let's practice multiplying some fractions, okay? Always remember to simplify. So if I have 4 times -3/7, I want to rewrite 4 as a fraction. So remember, any whole number can be written as a fraction over 1. Now I can multiply numerators and multiply denominators. Also, keep track of your negatives. Here I have a negative. A positive times a negative is a negative. So this is going to be negative 4 times 3 over 1 times 7. That's -12/7. Now, this is an improper fraction. You do not have to switch it to a mixed fraction, okay? I'd prefer if you didn't. So I've got -12/7. Can this be simplified any further? No. So I'm all set. Next, I have 7/3 times 2/8. That gives me 7 times 2, which is 14, over 3 times 8, which is 24. Now, this can be simplified, right? These both have a factor of 2. So I'm going to take a factor of 2, which would give me 7/12. And then I can't be simplified any further. This cat, y'all. Okay, so now if I take -3/5 times 4/9, right? It's going to give me a negative because a negative times a positive is a negative. So I have -3 times 4, which is 12, over 5 times 9, which is 45. Now, what do these have in common? Well, they both have a factor of 3 because I have to multiply the numerator by 3, and 9 is 3 times 3. So I can pull out a factor of 3 that gives me -4/15. Last but not least, I I have negative 3 halves times negative 9 over 1, which is just negative 9, right? 2 negatives make a positive. I'm just going to write positive so we keep track of that. 3 times 9 is 27. Over 2 times 1, that's 2. So I have 27 halves. Okay? That's my final answer. It can't be simplified because 27 is only factors of 3 and 2 is already a prime.